Hello friends, welcome to Yes Online Preparation League Season 2. Myself Sriram, working for Ace Engineering Academy since 2014, and I have more than 8 years experience teaching in GATE, ESC and various public sector units. Here I'm going to deal with digital logic design. And my dear friends, in this session, I'm going to discuss only the syllabus and importance of certain topics, even though they are not included in the syllabus. Some hidden topics of actual syllabus and how they can frame the questions in GATE for all branches such as electrical, electronics and instrumentation students. And in today's session, just this is my idea, and in tomorrow's session, I will select one of the topic from sequential circuits. It can be like a counters or a sequential circuits like a shifter register or some other topic. And after 20 to 25 minutes of brief discussion about the topic, I will plan to solve all the related questions, and you will get some idea about how the examiner can prepare objective questions in GATE and ESC from certain topic. As we have 1 hour time, I will try to manage and I will try to give some basic information of one particular topic only, that is about the tomorrow's session, right? And coming to the today's session, as I told you, I am going to discuss the syllabus and important topics. Topic order in the syllabus, topic order in the same subject such as digital electronics, and overall subject order, which subject should start first to continue the preparation without any disturbances. So I will let you know these points. And my dear friends, initially I am going to start with the ECE syllabus and important topics, but in the middle of that I can give you some information about electricals and instrumentation also. So please, my dear friends, even though you are from electricals and instrumentation, you don't need to skip the first 5 minutes video. Please, everyone, try to watch the video till the end. And definitely you are going to get some valid information. And before starting the syllabus and how they are framing the questions and some hidden secrets of actual syllabus, I'd like to tell you one point. In every live session, I used to say the same. We need some smart work. I don't believe only hard work can give success. It might be true in some cases, but in majority of the cases, some people can do the hard work. They can do from morning 6 to evening 6. But there might not be any growth because they may miss something in the hard work. If you could do hard work with some smart work and also hard work, we should love our job, even it is study, even it is a preparation, or it may be work in some companies, right? So then we can enjoy the journey of the total success. Success is ultimate goal, but the journey also has to enjoy by someone else, right? If they are in the journey, they should not take it as pain. If they take it as pain, they cannot move. So please, you need some strategies. You have to develop some strategies, planning, schedule, and you have to follow each and every schedule or preparation modules. This is a module number 1. I need to complete all heavy weightage subjects. That is a module number 1. Module number 2, I want to go with only moderate weightage but complicated topics. Like that, different minds can say different patterns. You follow your own pattern, you follow your own style, you follow your own strategy, and do not copy the strategies from others. We only know about our mindset, so we only can create the pattern or otherwise strategy that our mind can accept it. In such a way, if you could able to prepare the sheet about your schedule based on the syllabus and based on the subject order, please do not change the sequence of the subject. Even though some topics might not be there in syllabus, but without that topic, you cannot understand the rest of the subject. I will show you with proof. And how the questions will repeat. In GATE, as it is, questions will not repeat, but from the similar topics and similar model, we can find the questions. But no one can observe it. But if you could able to observe it, if you could able to break it, you will get some confidence. That is the reason the previous year questions solving technique is also one of the, like what we call a best part of our preparation. Okay, right. So this is what I told you. I don't believe only hard work. In some cases it may be give success, but we should do the hard work with some smart work, especially students, for the preparation of GATE, ESC or public sector. Each sector is having its own way. You need to crack it. You need to observe and you need to break that barrier. Okay, right. And if you love your work, automatically you can completely mask the time with love. You can enjoy it. You can enjoy the journey. Then you can, our ultimate goal is a success, right? Yeah, coming to the GATE syllabus for ECE, Electronics and Communication Engineering branch. Whatever I highlighted with the blue color, this is actually the topics they are given officially in the syllabus. This yellow color, data, this is not included in the syllabus, but you can find the questions. For example, in the recent GATE paper, there were one question found like designing of demultiplexer using designing of 1:8 active low output type demultiplexer using 2:4 decoders. 2:4 decoders. And in your old syllabus also you can see almost there are some changes. They made some changes of course, but almost this remains same. They did not change anything in this particular area, but questions are found from decoders, demultiplexers. And data codes and radix systems. This is quite common, right? Data codes such as gray code and BCD. Of course, BCD code related questions almost outdated, but we can't say questions will not come. We can't say questions will not come, but there is a chance. But even in recent GATE papers also we can find the questions based on gray code, XS3 code, and based on these topics, not only for ECE, even for electrical and instrumentation also you can find the questions, because they cannot remove this while framing the question. So even though it is not included in the syllabus, not only for GATE and ESC, even public sectors also, you please do not change the sequence of the subject. We are going to study and understand the subject. That's all. So you should not de-link any particular topic. Then automatically we will miss something in the sequence, right? And coming to the important areas. First of all, we cannot select any specific area. This is important and this is not important. But from some particular areas, we can find most of the times the repeated questions. For example, for electronic students, see IC families, in the old syllabus we have logic families, but here in new syllabus, they modified it as simply only CMOS logic. CMOS, of course, NMOS, PMOS. If you have good idea about NMOS and PMOS logic, then you can enjoy the CMOS logic design, maybe any logic gate design. Okay, right. From this particular topic, we can expect guarantee question in every year. Maybe 1 or 2 years they can skip this question, but in every year in general you can find guarantee 2 marks question from CMOS logic, 2's complement based system, and they don't give you the question directly. They will frame the question, right, by link up the 2's complement system with a parallel adder, maybe from the combinational circuit, or maybe some number systems. So for that they want number system, radix. For example, there will be some number. What is a decimal equivalent of 536? Some number in hexadecimal, 2's complement form and hexadecimal. So that their student has to use sign bit extension concept. So their examiner will assume student already good in radix systems, the conversions, radix conversions, and they're already good in 2's complement and 1's complement systems. So all these topics, even they are not included, they are not specified, but we have to follow all the topics as per the subject order, not as per syllabus order, as per the subject order, right? And see why every time or every year questions are found from CMOS, because you know well, it is in real time you can find most of the questions and most of the applications and circuit design are found by using CMOS logic, because it is a contemporary logic for the real-time applications and most of the real-time circuit designs and project works. Because this is actually forefront semiconductor device for IC fabrication. It is actually a forefront semiconductor device for IC fabrication, integrated circuit fabrication. It's most comfortable device. So it is one of the reason behind why the questions are giving. That means we should understand majority of the times questions are creating based on real-time requirement, real-time applications. That's it. And see this. For example, same syllabus. This is the syllabus. I'm going to highlight only combinational circuit. There is one question found from the combinational circuits. Sir, why have given this question? I'm not going to solve it, but I can do it. Of course, it is very simple. See, from the combinational circuit, everyone knows that this is simply a 8:1 multiplexer. It is having 3 select lines. So, student can write the Boolean expression A bar, B bar, C bar, or otherwise S0, S1, S2, S2 is MSB, S0 is LSB. They can write the Boolean expression, they will get the output. As all inputs are ones and zeros, they can get an idea. We can use K-map also to solve this kind of questions. But this is not a direct question. This is a point I want to highlight here. Most of the times, not only for ECE, even for electricals and instrumentation students also, the questions are giving by link up with some other topic. You cannot find the pure combinational circuit questions. Rare cases. We can find, but rare cases. See, this question is link up with logic families. TTL circuit. Of course, indeed, it is open collector TTL. So, one terminal is left open. Then what the student will think? This terminal is not connected to anything. It means examiner may did a mistake. That is the first kind of guess. And the second kind of people, they will think and they will make their own assumptions like this. Okay, as it is not connected to any variable and voltage, they will take it as 0 by default, but it is wrong. If the student know the subject means if the student studied the total subject without skipping any unit, then only they can solve every question in GATE exam. Because some students will feel combinational circuit easy, okay, I will follow it. Logic families, of course, as per the recent syllabus, the total logic families has been removed, only they have given CMOS logic. But earlier, we have total logic families in the syllabus. So, by that time, if student skip the topic, it is little bit complicated. They may lose a mark in simple topic, combinational circuit also, because the question is given by link up with logic families. In TTL logic family, I am writing here. In TTL logic family, open terminal, we can also call it as floating input. Open terminal should be considered as open terminal should be considered as logic 1. Should be considered as logic 1. Open terminal should be considered as logic 1. In case of ECL, emitter coupled logic, the same, if for any logic gate, it may be AND gate, OR gate, NOR gate, NAND gate, XOR gate, XNOR gate, any gate, if the terminal is open circuited, by default, the internal circuit of open collector TTL will accept it as logic 1 in open collector TTL. In case of ECL, emitter coupled logic, same thing, but it will be treated it as 0, logic 0. If the student having touch with the fundamentals and the basic idea about internal circuit and its operation, those students only can guess this point. They only can take it as 1 by default. That means at S2, no variable is exist. Why? Even though it is C, 1 plus C is equals to 1. So here C, a variable C is no longer exist. By default, S2 should be considered as 1. So, for example, just for formality only, I am roughly trying to solve the question. This is MSB bit S2, S1 and S0. Now, the problem will become very simple, right? Output will be logic 1. For example, if all inputs, for example, there is some combination. Magnitude of select line combination is 6, assume like that. See, which pins are connected to the logic 1? Pin number 0, pin number 3 and 5, 6 also connected to logic 1. So accordingly, student has to take the decision. Okay, I will do one thing. I will take S2. What is a S2? It is no longer a variable. So that means what? We always should consider ones only here. But sir, what about the remaining? S1, S0 can be changed from all in their initial states to final states like 0, 0, 0, 1, 1, 0 and 1, 1. That's it. And now this is the time to understand how it is going to produce the output based on the variables. Hello my dear friends. S1 is connected to a variable B. S0 is connected to a variable A. So we will deal with variables just little later down the row. First let me write the output, Y or Z, whatever, he given Y of course. Okay. What is the pin number? Which pin is going to select? Decided by magnitude of select lines. This is a key point. Once if student break it, the student can easily understand the problem. They can solve it in 1 minute. Okay, right. Yeah. See, some pins are connected to zeros and some pins are connected to logic 1. What is this pin number? It is pin number 4. It is pin number 4. And this is a pin number 5. Magnitude of select lines will give the pin number. And this is pin number 6. Just for model purpose, I have started the concept. I am just solving the question randomly. Okay. So I want to discuss more and more things about the question format and link of some XYZ year question to XYZ recent year question. I will reveal some of the secrets. Okay. So please keep on watch. 100 pin number 4. But my dear friends, pin number 4 is connected to 0. Pin number 4 is connected to 0, right? So output is 0 here. 111, pin number 7 is also connected to 0, right? Also connected to 0, output is 0. But 5 and 6, pin number 5 and pin number 6 are connected to 1. That's it. Now the point is, what is output? I cannot write the expression in terms of C because there is no concept of C. It is permanently connected at logic 1, that's all. Okay. So you are going to get the expression at output in terms of B and A only. Now you see B0, A1. That means how can you form SOP function? S1 bar, S0, but instead of that you take it as a variable, right? So B bar A plus B A bar, yeah. What is this? Output 1. When B0, A is 1. What is this? Output is 1. When B is 1, A is 0. So B bar A plus B A bar. B bar A plus B A bar. A XOR B is the answer. It is a 2 marks question given in GATE 2001 paper for ECE. As for ECE students, we have logic families in the syllabus. They are given the question by link up with logic families. I will show this type of questions for electricals also. Okay, little later down the road. Okay, right. And not only this, before starting the subject actually, because in this particular subject, we are going to study ADC and DAC. In ADC and DAC, there are 2 pillars. It's a topic, subtopic of digital logic design, that's okay. But there are 2 pillars. To understand and analyze each and every topic and problem in this particular unit, students should be very good in some basic elements of analog electronics, such as operational amplifiers and the network theory. Because you need to use Thevenin's theorem and sometimes superposition theorem in ADC and DAC concept. Strictly speaking, Thevenin's and superposition, these theorems has to use by the student to analyze the digital to analog converters, and especially R to 2R ladder network type. R to 2R ladder network, there are 2 types, voltage switching type and current switching type. So both are completely, it looks like an analog circuit. And to analyze it, students should be good in operational amplifier as well as circuit design, resistive circuit design. It is a fundamental from your network theory. So that is the reason, before starting the digital logic design, if you good in the basics, okay, that's okay. But in general, it is the best way, before starting the digital logic design, not only digital logic design, before starting any subject, especially for EC electrical instrumentation students, you better to start with a very fundamental subject, that is network theory. If you start your preparation with network theory, your journey, it will be like fruitful, and you can enjoy each and every moment of your journey. Because nowhere you will get disturbed due to some disturbances, like suddenly if you find some like network circuit, then student will get, okay, a doubt, okay, I did not complete it, so that I am unable to understand this. They will break it, they will start some other subject, so automatically it will miss the sequence. So confidently and happily the student cannot continue the subject. So that better you start with network theory and control systems. Then in each, I am not talking about digital, for every subject. If you start these 2 fundamental subjects, you can enjoy remaining all the subjects. Okay, right. And coming to this, see, here, this is an example. Why a student should be good in analog part and networks part to understand the digital in detail. Yeah, some of the topics in logic families and ADC and DAC. In these 2 topics only, definitely networks and analog electronics will definitely trigger you. Okay, right. You see, this is an operational amplifier. They have given very simple circuit, of course. It is simply a inverting type operational amplifier. Signal is directly given here. But we can just assume output is same as input, because no amplitude level and no resistor is provided, luckily. Sometimes they may give you non-inverting type. Sometimes they will give you inverting type resistor also. Then student has to find and modulus of output voltage. Student should know at least immediately, without writing node equation and virtual short and all those things. Immediately by look at the circuit, student should be in a position to write the formula, gain formula of op amp, minus R2 by R1. If it is non-inverting type, 1 plus R2 by R1. Like that, or it may be a current to voltage converter, and different switches may connect from the digital circuit. And different combinations of current can make the voltage at output. So the student should have a basic idea about current to voltage converter using op amp. But here, after started digital electronics, if you want to go back to analog and if you want to study it, it takes more time, and automatically it will mismatch the resonance, means your mind resonance. You are already connected to digital. Immediately if you open the analog, your mind will not accept it. Your mind will always give you some negative energy. Okay, you don't know anything about analog, first you start it. But already you have started the digital. And if you start analog, 80% of concept is linked up with again network. That is the reason you follow certain order. then only your preparation will be very smooth and you can enjoy the preparation, right? And you see the questions, it is actually from the counterpart. It is from the counterpart. It is a 3-bit counter. Something is missing, 3-bit up counter. And this is a digital to analog converter, 4-bit digital to analog converter. This was a question found in ECE GATE 2006, given for 2 marks. And the same question is given again, you see, the same question is given in some other exam. Of course, in the GATE, in some other year. I'm sorry, it is not some other exam, in the GATE exam only, and I think it may be 2000, some other year, right? But that is the reason actually. See, I already told you, your preparation should have some sequence. You have to follow certain pattern. How the examiner creating the question, that you should know. If I know all these things, what should I do? Yes, certainly, we can do what we can. We have to go through the previous year GATE papers. After completion of certain topic, you should go through all the topics, all the questions of the same topic, and you try to analyze the questions, you try to solve the questions. Most of them, I'm talking about previous year GATE questions, most of them already might be done by the faculty during the lecture, but even it has been completed by your faculty. You take the plain problem and circuit, you try in your own. Do not copy anything, any method from the notes. You try your own. So like that, you try to solve all the related questions from that particular topic from all the previous year GATE. Then you will get one idea about that topic. Okay, this is how the examiner is framing the questions. They are simply doing some small modifications to create the next question. So once if your mind is connected to that objective pattern, while reading any topic, your mind always will think in objective way. Okay, as this is a statement 1, 2, 3. Examiner can create this question by link up with 1 and 3, they can give the formula, or otherwise A equal to B plus C. In this particular way, they may give you B and A, they may ask the question about C. Like that, your mind will always think. So like that, we have to tune it. Tuning of your mind towards the objective preparation is nothing but preparation strategy. We should tune it. Otherwise, our mind will just read everything as a conventional, everything as like our semester exam pattern. It will not work out for the public sectors and GATE ESC. Okay, right. So why should I solve all the previous GATE questions? This is the reason. You see, this is a question found in GATE 2006 in EC paper for 2 marks. And this is a question, same, almost the same model found in, it is also found in, it's a recent GATE of course. I don't remember exact year of the GATE, but this is a GATE, I remember that. You can verify it. This is GATE 2000, something is missing here, but I remember GATE 2012 paper. And this is a question given for ECE and for 2 marks, GATE 2012, and you see this is a GATE 2006, almost same. One terminal is connected to ground. What will be the output given by 4-bit D2A converter? And this is Johnson counter. What is the output? Johnson counter. What is the shortcut? You should take one NOT gate here and you should write the sequence totally. 0, 0 bar, 1, 0, 0, 0 bar, 1, 1, 0, 0 bar, 1, 1, 1, 0, 1, 1, right shift and complement. But if you, one second. In the sequence, output sequence of a Johnson counter. It is not the problem. It is not given for the problem to solve here. It is just intentionally given to tell you some point. Counters, from the counters and DAC, see, these 2 points are only highlighted. By link up with these 2 topics, questions are given 2 times, 2006 and 2012. Okay, just formality, I am trying to solve it. Okay, right. Next, 1 complement, 0, 0, 1, and again you will get 0. So finally 0, 4, 6, 7, 3, 1. And that will well satisfied by one combination. You see, 0, 4, 6, 7, 3, like that. It is not visible, don't worry. In tomorrow's class, we will go for detailed problematic part. It is just how the student can solve this. Student can solve this, and if they leave it, what is the use? That's what I'm telling you. You analyze the circuit, you analyze the order, try to break down it. That means this time you should connect some down counter here and analyze the circuit. You take the operational amplifier as usual, you fix some gain, then you find the output. Like that, I want to tell you only the point about how they are framing the question, and why don't you frame the question, and why don't you guess the question? By doing some small modifications. That is my intention. My intention is not to solve these questions here, because today's session is only syllabus analysis. Okay, right. And see this question. This is a GATE 2012 problem. You will be surprised. Even it is not visible, don't worry. The state transition diagram for the logic circuit is shown. There is one circuit, D flip-flop, multiplexer, circuit is given like this. And they asked about state diagram at Q0. Q0 values, how they are going to change from one state to other state by changing the select line. That is a control line, of course. This is a question given from sequential circuit. You see, there is a sequential circuit and combinational circuit. You see, it is a question given from the combination of sequential circuit and combinational circuit, right? So, if student have an idea about both the concepts, then only they can solve it. And importantly, this is a question purely from state diagrams, not from finite state emissions, just basics of state diagrams. Hello my dear electrical and instrumentation students, you can also verify. This is a GATE 2012 ECE 2 marks problem. Immediately after the video, you download and verify GATE 2012 electrical and instrumentation paper. You can find this question surprisingly. Sir, how it is possible, sir? We don't have state diagrams. That's what I told you. You should not change the sequence of subject, even though it is not included. I will come to point and I will let you know your syllabus analysis also about electrical and instrumentation students, right? So first let me complete it, right? You see, so this is a question found in GATE 2012 for all ECE, electricals and instrumentation. Try to understand what I am showing here and what I am going to tell here. You try to understand the point, okay? Right. So the same question, see this line is connected back. Initially I can assume Q is 0. If A is 0, X0 will be connected to the output. After clock, if this is 0, Q bar value 1. After clock, output will be 1. That means if A 0, output 1. So 0 to 1. If A value is 0, output will, Q0 will change from 0 to 1. I will verify, okay, yeah, this is, if Q is 0 initially, if A 0, output is going to change from 0 to 1, like that. Of course, D is the correct answer for this question. That is not my intention, okay? I'm not going to solve the question. I'm going to show you how the questions are framing. Yes, 2012 paper, student has done this problem. Leave it. What is the use? Student should analyze it. Student should create new question, but without violating the rules and regulations. Next time, student should understand only one point here. Instead of X0, X1, he given X1, X0. That is simple logic, but the students who prepared this topic well, they can easily break it. But next time, students should think in different way. This is not D flip-flop. It may be T flip-flop. Then what will be the state diagram? In that way, if student could able to think, they can easily solve this question 2019 GATE. This is a surprise. See, this is 2012 GATE question. You see the circuit diagram? Statement, of course, statement. The state transition diagram for the logic circuit is given 4 options. Circuit is given 4 options. What is the difference? D flip-flop, 1, 0. See this? X1, X0. This is 1 and 0. Select line A, same. Select line A, only difference, instead of connecting Y to the input of D flip-flop, they made some modification. They have connected output to the NAND gate along with Q also connected. And this combination will produce new input for the D flip-flop, and once if you give the clock, it will decide the output. Of course, D is correct option for this question, but I'm not solving the problems, I'm going to tell you the pattern. Some secrets. If you do the analysis on the question papers, you will get something that can definitely give you some confidence. Your preparation will be like a some journey in Volvo bus. Just you can feel very happy, without any tensions, without any confusions. See, you should know, we should know what should I do. Okay, this is the first topic. I know I have some clarity about the next topic. And from next topic, I know there are 4 marks. I need to spend at least 4 days. I should do at least 100 questions from that. And then I should write short notes. There should be some clarity and the vision, right? And after completion of the total subject, I should revise it by taking some gap. That means what? I should start some other subject. After that, if I test my previous subject, then I can understand how many topics I could able to remember and how many problems I can directly able to solve. And even though some students may know thousands of formulas in their mind, they cannot solve the questions, because no matter how many formulas you can memorize in your brain, how effectively you could able to apply those formulas in the problems. In the correct place, on the correct question, at the correct situation, you should use the correct weapon. That is called the preparation. So that will come short of preparation only, practice, short of practice only. We need some practice. Close notebooks, close the short notes, close the material solutions, etc. You take the question paper. You just feel it is an exam hall. You try to solve it. You give some gap, like 10 days, some students 10 days continuously they will read the combinational circuits. And after 10 days, they will try to solve the problems from combinational circuit. Anyone can get the answers here. Even some students before writing solution also, they can remember the option. That is not good. After completion of, that is okay initially in the first time. But after completion of the total topic, you give some gap, go through the short notes just only once, entire subject, randomly you select the questions, then you test yourself. That is a correct way to test your subject knowledge. So that is the reason actually. Of course, we have PYQ, previous year questions, solutions also. So while we are watching the previous year questions, last 25 years, 25 to 30 years questions, you just hold the video. Do not play the solution. First you just see the question and how the faculty is reading the question, you try to understand. That is one of the secret, of course, most of you people may know. If you read the question properly, it can give 50% of the times, it can give you an idea. That is the reason, if you read one question, your mind will not sense any new point in that. But in class, if faculty is reading the question, indirectly your mind can, means faculty, they know how to read it. Reading the question, the state transition diagram for the circuit shown. That is the first way. The state transition diagram. State transition diagram. It is about state diagram. State means output of a flip-flop. How it is going to change. And who will decide it? Control line. That is a variable or select line A of the given multiplexer. So while reading the question, you should know how to read the question also. And you should write the given data. Of course, in digital, we don't have chance because almost all questions are logical questions. Okay, right, this is what I want to give you some information, guys. So I don't say questions will repeat, but if you could able to follow the trend, how they are framing the questions, you can easily catch each and every, logic behind each and every question in the forthcoming GATE paper also. Try to understand this, right? And question formats. What kind of questions we can expect, sir? Especially in public sector, only theoretical and logical, no numerical. But in GATE and ESE, especially in GATE, students should have a basic idea about numericals, analytical, logical, and least priorities goes to memory based question. 50 to 60% of public sector unit questions are memory based. Even in ESC also around 10 to 15%. But in GATE it is not like that. Okay, right. See, logical questions. That is what we have seen. We can see most of the logical questions in digital logic design. The subject itself, it is a logical design. Even the subject, some people will feel it is very simple. Digital, very easy. Just you give one GATE question. Simple. You just give one ECE or instrumentation GATE 2 marks question. Then you see their faces. They never say digital very easy. They will start saying digital, logical, interesting. It's interesting. It's logical, but not simple. Don't say simple, okay? Right. And numerical. Most of the times in GATE exams, in every subject, we can find the questions from numericals. Right? Means solutions, we need the derivation, we need to substitute so many values, we need to find the simplification, simplified answers. So that is belongs to the numerical. There is like not a simple questions. What is a 1000? What is a 1000 in, for example, 1000 is the gain of an amplifier. What is the value in decibels? 10 power 3, 20 log base 10, 3 into 20, 60 dB direct answer, log 10 base 10 is 1. That kind of things you can see in public sectors. But in GATE, compulsory you should use pen and paper. We should use a virtual calculator. There are some simplifications, and within the simplification itself, there are some hidden logics. You can see all these things in GATE questions, okay? Not in public sectors. Public sector questions are straightforward questions. And application, most of the times, you know, in every subject, real time, based on the current trend, they will frame the questions. Application based. After completion of one topic, you should know what is the exact application of that particular topic. For example, EC students, FSM, finite state mission. So what are the real-time examples of finite state missions? Why I should study finite state mission? Why Mealy and Murray circuits? Okay. Why? Definitely there is one question from the FSM in every year. 99.99% of the times, no chance to miss the question from FSM because it is a real time. It is a current trend. It is a current trend, and it is actually like what we call. It is actually the circuit you can find everywhere in the real time applications, right? Okay, next, memory based. Yeah, of course, I already told you. See, this is highlighted with new color, something different, blue color. It means you should give least priority for memory based questions. But there are some questions found. Some memory based questions also found in GATE, but it is only 1%. 0 to, I can say 0 to 2%, not 1, 0 to 2%, right? Yeah, see, for example, for all the branches, for ECE, instrumentation, and electrical students, for all the branches. For example, this is one question, I think it is GATE 97, yeah, it's GATE 97. Minimum number of MOS transistors required to make a dynamic RAM cell. It is from the memory. Yeah, this is a dynamic RAM cell. Of course, number of capacitors based question also found, right? So we need 1 bit, it is for 1 bit storage. We need only one cell. For RAM, for a RAM cell, we need only one MOS transistor. It is, nothing is there to do in exam hall on paper. It is memory based, but long back, very rare cases. For every 5-6 years, you can find 1 or 2 questions in the GATE. That is the reason I said 0 to 2%, okay? And one more second, right, I want. See, GATE, yeah, recent question here. GATE 2014 set 3. Static RAM, SRAM means static RAM cell, standard circuit using MOSFET. Of course, I did not provide the circuit, but it is given the circuit. It requires 6 MOSFETs. It requires 6 MOSFETs. This is the circuit implemented using MOSFETs, 2 plus 2, and then see the control part or control unit, word line and bit line. Totally 2 plus 2, 4 plus 2, 6 MOSFETs. It is also standard circuit. Even after 1000 years also, circuit will not be changed. Like, so this type of questions, very rare. It is belongs to, or these questions are belongs to the memory based, but very rare cases. In all subjects, in every subject, there is a scope to frame the memory based question, but less chances in GATE, more chances in ESC and public sectors, right? Now, let us see the electrical syllabus. My dear electrical students, please, I need your attention. GATE syllabus for electrical. See this, whatever the topics are the names I highlighted. With the blue color, these topics are given in official syllabus. These topics are given in official syllabus. But you tell me, can you understand half adder, full adder, parallel adder, serial adder, half subtractor, full subtractor, multiplier, binary multiplier, magnitude comparator, these topics without the basic knowledge of K-map, logic gates, Boolean algebra, literal, dual, self-complement, self-dual, without all these things, you cannot understand even a single topic in combinational circuit. And intelligently they have given arithmetic circuits somewhere. Arithmetic circuits. Arithmetic means it is related to arithmetic gates. Means indirectly they are saying you need to read logic gates. XOR and XNOR gates are called the arithmetic gates. And sometimes they will ask you within the combinational circuit how many NAND gates requires to implement a half adder. That means indirectly student has to know something about universal gates such as NAND gate and NOR gate. So please do not disturb the sequence of the subject. As per the syllabus, you just focus more and more on those topics. But you should have a basic idea and you should study well each and every topic as per the subject order. And they have highlighted these topics only. These topics, sampling and holding circuit, ADC and DAC, guarantee question from ADC and DAC. But as I told you, electrical students also, before going to start ADC and DAC, you should be good in networks. Better you start the networks. And after that, analog electronics. And then if you come to the digital, it is very simple and easy. And you can finish in that entire topic in just 4 to 5 days, right? So, and some repeated questions are found even for electricals also from logic gates and Boolean algebra. Even recent question paper also you can verify. One more important point. Here I want to tell you one important point. What is that important point? Sequential circuits, flip-flops, shift registers, counters, basics of state diagram. These things are not given actually, but you see the basics of state diagram. Just now I told you. In spite of the branch, maybe ECE, electrical or instrumentation, and in spite of the topics which are mentioned in the main syllabus, the student has to read each and every topic whatever I wrote on board, including basics of state diagram. Don't say sir, state diagrams, we don't have FSM, finite state machine, no need. Mealy-Murray circuits, no need for electrical and instrumentation. But you should know basic idea, basic state diagram. There is a logic gate having some propagation delay. How to draw the state transition diagram for that? There is a circuit, sequential circuit connected in series with one multiplexer or something. How to state transition by changing the combinations, how the state is changing. State, logic 0, logic 1. Output of sequential circuit is a state. How it is changing from 0 to 1 with what excitation, from 1 to 0 with what kind of excitation. Sometimes output is 0 with excitation, same data will be retains. It can, for example, output of certain circuit is 0. Even after giving one type of excitation, it can preserve the same data. So what is the reason behind that? And in all combinations of variables, input variables, how it is moving from 0 to 1 and 1 to 0. If you take it as a like graphical way, that diagram is nothing but the state diagram. But I cannot give you detailed information now, just I am giving you the hint, okay. So don't skip, even though it is not included, but you better go through it. Including data codes, BCD, XS3 and radix systems, binary to decimal to all other number systems, all other number systems to decimal, and leftover are octal to binary, binary to octal, hexa to binary, binary to hexa. Two conversions are left, octal to hexa, hexa to octal, total. You should have a basic idea about all the conversions. There are around 12 conversions. You should have a basic idea about all the conversions, okay, right. And you see, this is a question, surprise for electrical students. GATE 2014. This is a question given for electricals. I am writing here, electricals. You download the paper and verify, electricals. But this is the state diagram. Of course, state diagram of a certain logic gate. They will give you the data, logic gate which exhibits delay and what is the state transition of which of the logic gates can satisfy the given state diagram. Some data, of course, but it belongs to state diagram. They have given it for electrical, and even in 2014 electrical syllabus also you can find, you do not find the state diagrams in the syllabus. But questions are coming because examiner will have some positive mindset about the students. Okay, student as he is from engineering, they should have basic idea about all the concepts, right? So that the students should understand it, students should get it from analyzing the previous gate year question papers only, right? Yeah, of course, for this circuit, see, if any of the, all inputs are, this is actually input combination, and inside the circle they will give you the output. If inputs are 1, 1, output is 1. That is only the case. If any of the input, 0 don't care, 1, 0. If any of the input is 0, if any of the input is 0, see, output is 1. Output is 1. Actually, by mistake they have given this, it should be 0. It should be 0, right? It should be 0. By mistake they printed 1 there. It should be 0. If any of the input is 0, output is 1. Sir, present output 1. Again, if any of the input is 0, output is 1. Output is 0 only when inputs are 1, 1. 1 into 1, 1, 1 bar, 0. And 1 plus anything 1, and its complement is 1 plus anything. See, I'm sorry, 0 into anything, 0 into anything, I mean 0 dot anything, 0, and its complement is 1. So I can compare it with NAND and NOR. Luckily, we don't have NOR in the option, but directly we can understand as one of the input is 0, output is 1. At least one input is 0, output is 1. So 0 plus anything, 0 plus anything, output 0 plus anything, 0 plus 1. For example, if I take it 0 plus 1, yeah, 1 plus, 0 plus 1. No, actually 0 plus 1 or 1 plus 0, output should be 1. This is a way you should do the analysis, because we don't know. If we know, if you know basic idea, you can immediately select the option. That is different story. But I'm thinking, I don't know anything. But how a certain circuit, certain logic gate, you take circular box, no problem, is providing logic 1. Is providing logic 1 if any of the input is 0. Right? There are two ways. 0 into anything 0 and 0 complement value. 0 complement value is 1. Okay, satisfied. This is not going to satisfy it. Next, output should be 0 if inputs are 1s. Yes, correct. If both the inputs are 1s, 1 dot 1, 1 and 1 complement is equals to what? 0. If any of the input is 0, 0 into anything or anything into 0. 0 and 0 bar is equals to what? Logic 1. So that I will get, or this state diagram can be satisfy the NAND gate. But I can change this from 0 to 1 and 1 to 0. For example, you change it, values. Otherwise, these combinations, they may be change. Like that, you can see, you can find in notes also, you can find this type of state diagrams for all logic gates, including NOT gate. Including NOT gate, you can draw the state diagrams. Including NOT gate, you can draw the state diagrams. Input 1, output 0. This is 1, okay? This is 1. Input 0, output 1. Input 0, output 1. Input 1, output 0. This is the state diagram of NOT gate. Similarly, you can find the state diagram for 1's complement. It is, NOT gate means 1's complement operation given in computer science. CSE, IT, 1 mark bit. This state diagram can satisfy 1's complement, 2's complement, some OR gate, XOR gate, but only one input, either 1's complement. That's it. No option, no alternative. If you verify the options, you can easily deselect on all unnecessary options, because this system is having only one input. Input 0, output 1. Next input 0, next output also 1. Next input 0, next output 1. If next output 1, next input is 1, output is 0. On the line, we are writing inputs. In the circle, we are writing the outputs. Just rough explanation, okay? We are not studied anything in this particular session. Just some rough explanation. So students should understand how they should start their preparation and for which topics they have to give the priority, even though some topics are not clearly mentioned in the syllabus. The electrical students should know something about, something about basics of state diagram. Basics of state diagram, right? It is not visible, don't worry, and values also, by mistake it is given as 1, don't worry about it. Just you think about the model. Next surprise, this one. This is a 2012 same electrical, you can download the paper and verify. You will get option D for this, okay, whatever may be the state diagram based question, 2 marks question, but given for electrical. So, you don't skip this topic. That is actually the point I want to tell you. And coming to the instrumentation. See, my dear friends, whatever the things I highlighted with the blue color, these topics are given in syllabus. Yellow color, it is a order of the subject. Order of the subject. By excluding these things, we cannot find a standard order for the subject. You cannot understand the subject. You will not get overview. So that compulsory you must follow the order like this. Before this, within the Boolean algebra, there is a basic concept called literal cost. What is a literal cost? What is a circuit cost? Circuit cost means it's not the price, okay? Or logic gate cost. It is not price. It is about the number, of course, number of logic gates, right? And dual, self-dual, complement, all these things will come under the fundamentals. Then minimization techniques. After that only you can enjoy the combinational circuit. And for you also, of course, they have given clearly like IC logic families, TTL and CMOS. For ECE, only CMOS. But you need N and PMOS, okay, remember. Electrical, no need of logic families. Electricals, no need of logic family. Instrumentation students, CMOS and TTL. TTL again, there are some classifications, right? TTL, open collector TTL, two-time pole TTL. Just have a look, but questions will be mainly from CMOS logic, right? So don't neglect it. And I want to tell you one point. Critical path delay. It is just delay based question. Of course, recently it is included in syllabus, but questions are found from last 15 years. Without, definitely in regular, this is the regular question in EC paper, instrumentation also, and rare case for electrical students, they are asking the simple questions for them. But instrumentation and ECE, you will have the same style of questions and the same, almost weightage is also same, around 7 to 9 marks. You can expect from 7 to 9 marks, but for instrumentation students, they are giving the questions by link up with your transducers and electronic measuring instruments. They will connect one digital voltmeter at the output. They will ask you at the output of one D to A converter. They will ask you the percentage of error, accuracy, these kind of questions. They link up the questions with your core subject. I am talking about instrumentation students. Even for electrical students also, they are giving the questions from DAC by link up with our measurements subject, right? And you also please don't skip this point. What is one point here? Yes, I think it is FSM. So far we talked about FSM only for electrical students. The same is applicable for instrumentation students also, because questions are found. GATE 2012 paper, instrumentation students you can download. You can find one question from the state diagram, not from FSM, finite state mission, state diagram. No need of finite state missions, just basics of state diagrams. Basics of state diagrams. State diagrams. It is just I think maybe 1 to 2 hours topic. FSM is little bit lengthy. It is 4 to 8 hours topic. It depends on the weightage. For EC, GATE, it requires around 4 to 5. For ESC, it requires more number of hours. But for you, electricals and instrumentation, no need of FSM. You need only basics of state diagram. It takes only 1 to 2 hours. You just go through the fundamentals. In any textbook, you can find them. Okay, right. This is about the some basic information. Whatever the things I have given for ECE and electrical, same things will applicable for instrumentation students also. But your weightage and syllabus is almost equal to same as ECE. Instrumentation syllabus and weightage is almost same as ECE, except FSM, no need. But ECE students don't have TTL, but you need to read TTL also. Okay. Right. So classroom notes, majority of the times, students will blindly follow only previous year questions. No, not sufficient. First, you should have some fundamental knowledge. You should solve the classroom notes problems again and again till to get some confidence and command. You need to do some mistakes at the time of preparation, but not in exam hall. You should do some mistakes. If you commit a mistake, you just do accept it, and you do think what went wrong, and immediately should realize, okay, something went wrong. So what might be the problem? You realize it, immediately bounce back and start the preparation. And you no need to disappoint at any point of the time during the preparation, because it's quite common for everyone. Without failures, no one will get the success. So you just keep on practice. That is your motto. That should be your positive thinking. You always be confident and always be with some positive energy. Even if you do some mistakes, sir, I studied this topic 10 times, sir. Still, I could not solve some problems, sir. Not only you, so many of you and so many of your friends, 80% of the students might have the same problem, because it might be a complicated topic. If it is not a complicated topic, what is the difference between you and others? You spend more time on that. Wherever you find the difficulty on those areas, you spend more time. You go to textbook, go to YouTube, and go to Google. You search, you just try to utilize all the resources properly. If you could able to utilize the resources effectively, it can give you the success, no doubt, because that much chances actually we have nowadays. Okay, olden days, people don't have this many number of facilities to get the data. You can easily procure the data related to a certain topic once if you have any doubt. Like in olden days, people have to go for only textbooks. They need to refer 10 to 15 textbooks. Then only they use it to get the clarity about the topic. But nowadays, not like that. Not like that here. You can just ask anything to our Google. Google will give you the detailed information. But go through a valid websites only, but randomly you don't go for the search and don't collect the wrong data. You go through some valid and standard websites only to get a valid data. Okay, right. So next, GATE and ESA objective bits. For GATE students, the students who are preparing for GATE, you focus on GATE last 20 to 25 years of previous year questions. Of course, some of like our PYQ questions are also available, right? But you please don't damage your actual talent by following or by watching or by reading the solutions directly. It is not good. You pause the video, otherwise if you are reading from the previous object, different materials are available in the market. While even if you purchase it, if you don't see the analysis, solution immediately, take the question and options, you try your own. Even it takes more time, no problem. We need more accuracy, accurate output. Accuracy means accurate output. And slowly we can improve yourself so that you can increase accuracy and you can decrease the time. But indeed, initially, if you try to increase accuracy, time also will increases. But after completion of initial days, you can do some modifications in that. You can bring some changes in your what we call a way of preparation. You can increase accuracy and decrease the time. But immediately don't try to get everything just within 1 or 2 attempts. It's not good and not possible. Okay. And short notes. Some students, I use it to say the same thing for every year, even YouTube live sessions, in classroom and recorded videos, in live sessions, everywhere I use it to say the same thing. But what the students do, see, they will write the notes. Immediately at the time of preparation, they will try to write the short notes. If this is the size of notes, they will get as it is, Control C, Control V, copy. How can you say this is a short notes? How it can be a short notes? No. You will get copy, handwritten Xerox. You will get handwritten Xerox. Short notes or preparation of short notes is not initially in the first time. After 2 times of revision, after solving so many questions, then, first you have to watch the videos if you are following the recorded videos, or if you are going for any offline classes, you follow the notes completely, you read it again and again, and you try to solve all the questions. After that, you should take the notes and prepare a short notes. It doesn't mean writing the things in small letters. The entire subject should write, just finish within 4 to 5 papers. It should not be more than 4 to 5 papers. You should complete everything in single line. For example, logic gates. What is the point we have to remember about NOT gates? If odd number of gates connected in closure loop, odd number of gates, it can be a stable multivibrator producing frequency square wave, and frequency of square wave is 1 by 2 times that of n into TPD. That is one line only. Sir, even number, output frequency is 0. Like that. You should write in one line the entire topic. There might be n number of questions. Don't care. Once if you read that one line, you should recall the total data, because it is just like a password. Short notes is a password for the big information, original database which is available in our brain. And you have copied that content from notes and materials and different objective books into your brain, and your server is maintaining that. For that, password is short notes. Every day, just before going to bed, you just open the short notes. In 10 minutes, you should complete 5 subjects. Sir, how? Yes, it is possible. You try it, you will feel it. Because small notes, pocket book, enough to write complete subject. It is just like a password. If you read one line, you should recall the total related data, formulas, whatever the problems you have just solved at the time of preparation. You should recall the total, entire history. Like that you prepare. And you don't ask your faculty, sir, provide short notes. How can you understand their short notes? Can you use some other password to your mobile? How it can work? Similarly, short notes means you have to prepare your own short notes. Okay, right. You remember, please don't skip these points. Very important. 100%. I hope these things will definitely help you. Okay. And after that only you should go for textbooks. There is, for example, there is one topic in sequential circuits. If you, for example, there is one topic like synchronous counter design. You could not able to get the clarity from the notes. Then you take R.P. Jain, A. Anand Kumar. There are so many textbooks available. You download the PDF. Otherwise, you take the 2 to 3 different types of textbook. No second thought. Just relax. Take only the topic. Read it. You get the information. Same, another textbook. You try to understand what kind of information and example questions are given in that textbook by that author. You try to understand the author mindset and how he is giving the information in the book. And you go to another textbook. Then by that time you will get some clarity. Then you just combine all valid, basic, standard informations from basic level to the extreme level and copy all the questions on one paper. Then you change the numericals. You create your own way of 1 to 2 questions. Then you believe me, you will get full clarity about the topic. Preparation is different, reading is different. Please do not read the textbook from first line to last line. You try to understand, read the line and stop there and think it. Spend some time for thinking also. Right? You need to give some time for the brain to start the thought process. Every time storage means no use. You should give some time for the brain to start its own thought process. Okay? So, sir, for every topic you cannot find in textbooks. For example, in counters only, you can find there are 2 questions found from last 20 years in ECE paper. Asynchronous counter with synchronous clear. You cannot find it in textbooks. You have to go through the classroom notes only. Otherwise, you should go through some IEEE papers. Otherwise, you cannot find it in textbooks. So, there are some topics you cannot find in textbooks. So, there are some questions you cannot find, you cannot see that model also in textbooks. Because that is a creativity created by IIT professors. So that we should take the total data and with the help of that data and that confidence only we can solve some of the questions like that. And objective books, that is the last priority. Because if you have some time, then you can happily take any objective book or otherwise PYQ, what we call recorded videos or otherwise you can download the previous year objective bits. There are different sources available, different sources. You can choose anyone and then you can practice those questions. But please, you have to choose while preparing objective bits, you have to choose the best publication and there should not be any mistakes, and then you try to solve it, because even if you find one or two mistakes, you should be in a position to correct it. You should not follow it blindly, because you are already good in subject by doing all these things. And you write one table. What are the important topics? How many topics are there? There are some topics. Topic number 1. 10 marks are coming from the topic. Example, networks. And from how many areas the questions are repeatedly giving. Whether you are good in that topic, in that subtopic, in that subject or not. Verify, cross check. Yes, 2 times preparation is over. Preparation 2 times over. Revision 1 time over. So after another 4-5 subjects, again you should go for the revision. Of course, short notes is already ready. Short notes is ready, but again after 4-5 subjects, you need to revise it. For example, power system, around more than 12 marks. Total missions, more than 12 to 15 marks for electrical students. So analog electronics, networks and controls, these 3 can give more than 30 marks for EC students. Like that, there are some set of subjects. You should verify and you should analyze the previous year questions. What is the weightage and what are the repeated questions from there, whether it is very tough subject or simple subject or linked subject. You cannot understand, for example, EC students, communication systems, analog communication systems without signals and systems. No option. You must go through the signals and systems, then only you can enjoy communication systems. After what we call networks. After networks only, you can go for networks, and after that analog electronics, and then digital logic design. This is an order. If you have microprocessor, after digital, you should go to the microprocessor. That is the order. EC students, computer organization, right? So there is certain order, then there is no disturbance in the preparation. You should like feel it as a very smooth, like a road, just like a cakewalk, right? Means at the time of preparation, you should not get headache while reading certain subject. Yes, if you will definitely feel it, if you are not following the order, if you are blindly reading the subjects without any strategy, without any proper plan. That is the reason I told you in the beginning of the video. Hard work is not only important. Someone is reading 22 hours per day. Someone is reading only 4 hours and 2 hours he is thinking what he just read and he is trying to recall the data. The second person is the intelligent person. Just if you keep on writing the notes on rough papers, you can make n number of Xerox notes. What is the use? You should understand it. You should own the subject. You should, if you can feel you are good in the subject, if you could able to create your own question. After one topic, you study transformers. There is one topic. Yeah, auto transformer. Whether if you feel, if you could able to prepare at least 2 to 3 questions, typical questions from that topic and the gate level, then you can understand, okay, I am good. You should able to create the question with high level logic without any violations. Without any violations, you should create the question. Creating the question means only by taking standard circuit, what is advantages, disadvantages, what is the output power, what is the, not like that. The typical question, some logical question, you could able to create. That means you are giving the preparation to your mind. Hello brain, you are going to get this kind of questions in exam. So that you need to understand the logic behind each and every topic, then only you can understand the gate question. Right? So this is a way to prepare for the gate, not only for the gate, even in ESC and public sector units also. And my dear friends, I hope this session will really help you. And in the next session, I'd like to select one topic. Otherwise, you can just give me a comment, and accordingly I will select the topic. Just by tomorrow before 3 o'clock, if you could give me the comment, I can select that topic, and I will come up with like some example questions by explaining that. Within 1 to 1.5 hours, I can select only maybe from typical areas of one topic, and I can give brief explanation, and after that I will go with some related questions and logical questions. How many topics we are studied is not important. You are going to know how to study topic, how to study a subject. If I take one topic, what are the boundaries of the topic? And beyond the boundary, if you want to think, what should we do? So these kind of things I can definitely tell you in the next session, right?
And if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy, and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy, and if you will work hard, you will definitely achieve your goal. Thank you.